So, hello Ben. Thank you for agreeing to talk to my CS270 class and do a video that we can put online about using NoSQL, NoSQL tools and modern stuff. So, first up, could you just introduce yourself and say who you are and what you're doing?
Yes, so I am a technology architecture analyst at Accenture. It's a world-leading consulting technology services and outsourcing company. We help our clients reach their maximum potential and reach high performance through delivering consultancy work, developing and deploying technology solutions. And we help organizations of any size all over the world. It's really exciting work that we do.
Okay. So, what does NoSQL mean to you now, as someone new into the field?
Yeah. So since leaving Aberystwyth, since graduating in computer science and AI, I now work on project-based work. The project I'm currently doing, we are using NoSQL based databases, and to me now, I understand how important NoSQL databases are. There's 5 key components to NoSQL databases that I see now. The first being that they are non-relationable. We are storing vast amounts of semi-structured data in our Hadoop database. We'll talk about this later. But we have a lot of product information where we have many key value pairs. So our rows in our database may share 1 or 2 similar keys, like an ID, and then may have secondary attributes related to that product, which are completely different. So we need a database where we can store lots of data, semi-structured data, and we can pull that information out quickly. And I'm talking terabytes to petabytes worth of data here. So that's the first key point. The second point of the second common factor that I've now discovered or seen with NoSQL databases is that they offer eventual consistency, and this is due to a lot of NoSQL databases running on distributed systems on many machines. This offers very high very good processing capabilities, and that data can be processed very quickly. However, it can take a while for that process to propagate throughout the your node cluster, your database ecosystem. The third one, the third main common feature of NoSQL databases is that they're open source, and there's a huge array of technologies that are used in these NoSQL database environments. So, talking to Hannah earlier, I work with Hadoop, Hive, HBase, Apache Kafka, Apache Spark. They're all open source technologies that are there to help move data in and out of NoSQL databases. Fourth point, as I mentioned, they're typically distributed systems. This allows us to perform functions which may be classified as MapReduce functions, where we split processes or tasks between many different machines to enable faster processing, and then we reduce all those results back down into one result. And the fifth common factor I've seen with NoSQL databases is that they're ideal for what may be termed as web scale companies. So Google, Facebook, Amazon, companies that may have millions of users online at any given time, performing potentially fairly simple requests, logging in, liking stuff, commenting. Millions of these actions go on every second, and you need this to be processed quickly across a cluster of machines.
Excellent.
So that's what NoSQL means to me now. It's very important.
I'm kind of reassured that a lot of that is stuff that I've talked about in my NoSQL lectures in just this term that's just gone by. So I've obviously picked up some of it.
So I had to revise it since.
Well, it's moving so quickly. I think it's the part of the module that I update the most in the 2 years that I've been teaching it. It's moved so far. So what's the coolest thing about working with NoSQL systems?
Well, as I said, there's so many technologies involved with NoSQL databases. So the project I jumped on, we're doing we're live streaming lots of data from a variety of different data sources. We stream that through Apache Kafka, transform it using Apache Spark, and eventually store it inside Hadoop, from which we can do all manner of things. And there's a machine learning team that we work with that is able to access that data using Hive and perform some great forecasting analytics on the data. So it enables us to quickly draw business insights out of unstructured data that would be difficult to draw insights out of otherwise.
Okay. And what was the hardest thing about coming onto this kind of project?
Again, the technology. So I joined. I'd never heard of this these technologies before. Really, I knew what a NoSQL database was, but I hadn't heard of Hadoop before. And it's essentially a framework for distributed storage and processing of data, which has become really important now. But yeah, getting my head around all the different systems, reading so many different APIs, languages. So some of the technologies use a programming language called Scala, which is pretty new. There's not so many people out there that know Scala, but it's quite similar to Java. It runs on the JVM. But yeah, new programming languages, new APIs, new terminologies, a lot to take in.
So, they call it NoSQL, but my understanding is that a lot of these systems kind of have bits of SQL in them. So I'm guessing
you typically write a program to access NoSQL data. However, I briefly mentioned that Apache Hive is something that you can run on top of your Hadoop database, which allows you to access or try and access the data with SQL language. So it enables those who may not be so technically savvy, so well tooled up in the programming world to access that data with a SQL interface, which is something that's a bit easier to understand.
So all of those lectures on select from weren't completely wasted.
No, still using them now. I'm trying to use them.
Excellent. So is there anything that we haven't talked about yet that you want to talk about with relation to this?
So I can talk a little bit more about Hadoop as the NoSQL database we're using.
Okay.
It's made up of three key components. You've got the HDFS, which is the underlying file system where you're eventually storing your data. This is fault tolerant, scalable, easily scalable, and is fast to reach. MapReduce, as mentioned, which is the process of splitting your processes up into many small processes and reducing the results down into one result. And Yarn, which is like a resource manager. You'll find with a lot of distributed systems which come with NoSQL territory, is that they need a resource manager to allocate memory, CPU, and things like that, to ensure that every machine is running at a sort of almost consistent level with every other machine in the cluster. Because
otherwise you might end up with different parts of the cluster having too much load, right?
You might have nodes or servers machines within a cluster. You want them all handling the same amount of data roughly. You don't want one machine doing lots of work and then another machine just hanging there, sitting there, not doing anything.
Okay. So is that resource management interactive, or is an element of that handled for you by the Yarn kind of?
A lot of it is handled by Yarn. I mean, there's a number of configuration files you can change to determine how you split up your data, how you replicate your data across your cluster, which is extremely important. And you can get some interfaces to get a nice graphical user interface on your Hadoop cluster. Something called Apache Zeppelin is nice for creating graphs and monitoring the health of your cluster.
I love the Apache names. They've all got they all sound so futuristic. Apache Zeppelin. Hang on, welcome to 1942.
Lots of stuff.
Okay, cool. Well, thanks a lot for that, Ben. That's really useful, and it'd be nice for, I think, the students next year to see an grad actually using this stuff and also being really enthusiastic about it. It's great. Cool.
Not a problem. I hope it helps.
Thank you. Cheers.
No problem. Cheers. Thanks. Bye bye.